Hello and welcome everyone to our second episode on Tech Nuggets. I'm Patrick, I'm Managing Director at FEV Consulting Iberia, and I'm dialing in from the city center of Bilbao, northern Spain. In the first episode, Johannes talked with Marius about fuel cells, and we decided to stay with hydrogen, but this time discuss the combustion of H2, so focusing on H2 internal combustion engines. I will discuss with Lukas, a true expert in that field, a couple of points such as technology changes, industry trends, and our expectations in terms of market rollout. I'm sure you will enjoy it. Stay tuned. Thank you very much. Hi, Lukas.
Hi, Patrick.
How are you?
Good. How are you?
I'm great. I'm looking very much forward to discussing H2 ICEs with you.
Yeah, me too.
Lukas, can you share a bit of your professional background, please?
Yeah, for sure. So I joined 2016 the FEV company as a technical specialist for gas engines after I did my PhD at the Aachen University. Then 2018 I was announced as product manager for medium duty and heavy duty on-road engines. And 2020 I became the product manager for commercial hydrogen engines.
All right, I see the absolute right guy to talk to when it concerns H2 ICEs. Lukas, we thought of providing our audience a couple of personal points as well before moving into the technical part. Are you okay with sharing and answering a couple of surprise questions?
Yeah, I will try my best.
Okay. Let me start with the first one. Lukas, what was your first car?
Oh, my first one is actually still my only one. It's a 2011 A3 Sportsback.
Okay. May I ask which type of engine?
Yeah, sure. It's a 2-liter diesel engine, 140 horsepower.
All right. Lukas, moving from cars to sports, soccer or Formula One?
Oh, since I played it for quite a long time by myself, it's soccer.
Soccer, all right. But now the most important question, Bayern Munich or Borussia Dortmund?
That's a quite easy one for a guy living in North Rhine-Westphalia. That's clearly Borussia Dortmund.
I expected that, to be honest. Okay, now let's move into the technical discussion, if okay for you.
Yeah, great. Let's start.
Great. All right, Lukas, let's start with the technical part. And my first one is, I guess for you, an easy opener. Can you explain us what is an H2 internal combustion engine? What is the main difference in comparison to a diesel or gasoline engine concept?
Yeah, it's actually rather simple. The main difference is the fuel. So whereas for sure diesel and gasoline engines based today more or less burn fossil fuels, the hydrogen engine can burn renewable produced hydrogen and is tailpipe then in terms of the fuel CO2 free. So the fuel does not contain any carbon and therefore the combustion does not produce any CO2 related to the fuel.
I guess that the source of that H2 is very, very relevant when it concerns the discussion on CO2 neutrality. But maybe that's a point we will touch upon later today. Understood. Let's start then and discuss further on the let's say current industry perspective. I have heard. I guess we are all aware that MAN announced first vehicle tests with an H2 ICE end of this year. I've just seen a press release that Toyota announced applying an H2 ICE in race series. So what does it tell us in terms of industry readiness and attractiveness for different industry players?
Yeah, it's basically the key for H2 ICE development at the moment is mainly located and the core is within the medium duty, heavy duty area. So we see a strong interest, especially in the engine ranging from 7 liter to 15 liter and a little bit beyond that. There is definitely where the industry is focusing on at the moment. Out of that core at medium duty, heavy duty, we see now the interest spreading So the technology gets more and more involved, and therefore is also suited for other applications where internal combustion engines will also play a major role in the future. And that is, for example, racing, where that experience of sound and vibration is really much needed to transfer basically the spirit of racing.
What do you think is the reason that the main interest was generated first in commercial vehicle applications? You mentioned 7 to 15 or 16 liters. Why is that? Why is that the first rollout scenario we would foresee?
Yeah, it's basically the possibility to apply pure battery electric propulsion systems to the vehicle. So for passenger cars, due to the lower weight and the lower performance requirement, for sure it's easier to realize a pure battery electric vehicle in the segment of passenger cars, whereas with increasing driving distance and with increasing payload, the average power demand significantly increases, and therefore the alternative of pure battery electric vehicles is not that much given for the long-haul truck segment, and therefore other alternatives which are reliable, robust, and well known are a little bit more in the focus.
Understood. Lukas, now coming a bit into the, I would say, technical boundary conditions or technical requirements, can you explain the audience what are key technical changes on the combustion engine itself to basically allow a combustion of hydrogen?
Now focusing on the medium-duty, heavy-duty segment, where for sure diesel engines are the major application at the moment, and coming from that diesel combustion principle, which is basically using direct injection close to the top dead center, and then the fuel is ignited by itself due to the high temperature within the combustion chamber. The hydrogen combustion, as we see it today, will definitely start as a spark ignited principle. So we know that principle in the heavy duty segment already from CNG engines, compressed natural gas engines, which are also running in the majority as a spark ignited concept, and that will be also the first engines in the market using hydrogen. So they are a little bit taking the technology from smaller engines, gasoline based engines with that spark ignited principle, and transfer that to the heavy duty segment.
And would you see a trend towards direct injection solution? I guess that the injector is a key challenge here from a component perspective. So what is your view on implementing, or let's say focusing stronger on DI solutions for hydrogen combustion?
Yeah, absolutely right. With natural gas in the past, we saw some development activities developing solutions which also would allow CNG direct injection, but the drawback using CNG was not that significant. So CNG, for example, does not has this high volume, and therefore the drawback using PFI compared to DI is not as huge. With hydrogen, for example, you have quite a large volume the hydrogen is taking, and therefore the boost pressure demand is significantly increased using PFI, and therefore the pressure to develop DI systems is much higher. And that is what we see in the industry now, high pressure on this development of this DI technology.
What is your expectations in terms of series readiness for DI solutions?
So we see definitely a lot of major injector suppliers working on that topic, and market readiness in terms of really robust serial production will be in the range of 2025.
Understood. We discussed now a bit on the combustion engine itself. Let's look a bit to the area of the storage system, the hydrogen tank. Can you describe current solutions, expected solutions, and basically impacts on the successful and wider rollout of H2 ICEs?
That again, we can basically also compare that a little bit to the natural gas, so that is a little bit a look in the past, what has been successfully implemented in that area. So we see that compressed storage of a gas, especially suitable for applications with less demanding drive cycles. That will be then city buses, regional delivery, urban delivery. There, a pressure level of 350 bar might suit the customer's needs. Whereas if it's going to larger driving distances, we see definitely an increasing trend to go for the higher pressure level, which is then located at 700 bar, so gaseous storage of hydrogen at 700 bar. And within the next decade, we also see liquid hydrogen as an opportunity to even further increase distance and basically increase the energy stored on board of the vehicle.
Understood. I guess that has a big impact again on the infrastructure of hydrogen, right? I mean, the pressure level you need to provide the customer with, if I think about, for instance, long-haul applications, I would expect that it is quite a way and quite a challenge we have in front of us.
Yeah, absolutely right. So the amount of hydrogen fueled by a passenger car is rather small compared to the amount of fuel basically taken by a heavy-duty truck. And therefore, even though the pressure levels are the same with 700 bar, the tank technology behind it is rather different. And therefore, we see definitely that sharing the same pressure level and also the same fueling protocol is definitely an advantage. And their pass car and heavy-duty truck might take the same route, whereas the fueling amount for heavy-duty trucks is significantly higher, and therefore the technology a little bit more tricky and a little bit more difficult to realize.
Understood. Lukas, we talked a little bit about the modifications, and you touched upon the topic of the injection system. Now, I would imagine that you can perfectly derive an H2 combustion engine based on an existing concept, as we discussed at the beginning, a gasoline concept, but also at later stages, a diesel concept. Now, would you see further technical potentials when doing a clean sheet development for H2 ICEs?
Yeah, it's actually then combining that base technology well known in the passenger car segment, where gasoline engines are operating with a pent roof cylinder head design and a tumble charge motion, and basically transferring that knowledge to the heavy duty segment, which is at the moment in the majority a flat cylinder head design and a swirl based charge motion, basically taking over from the diesel engines. Combining these technologies might create a benefit in the future, whereas at the moment where in the startup phase production numbers for the hydrogen combustion engine in the medium duty heavy duty segment might be rather small, it's a really important key to be able to manufacture these hydrogen engines on the same line as a diesel engine, and therefore the difference is not allowed to be as huge as it would be with a clean sheet design.
But you would still argue that over the course of the next couple of years we can expect such clean sheet developments for certain target applications where, let's say, technical specifications and performances really make the difference for the end user and for the use case in that technology application.
Yeah, it's definitely the question of market penetration of the H2 ICE development. So if we see increasing number and increasing market potential beyond that certain step where then dedicated production line makes sense, then the next step in engine efficiency and power density can be basically taken with that clean sheet design.
Okay, Lukas, I want to come back a little bit to the point you raised at the very beginning, the discussion on CO2, and I could phrase it in a very simple way. Is that clean? Is that really clean?
In terms of the fuel, which does not contain any carbon, the combustion of hydrogen itself does not produce any CO2. For sure, in internal combustion engines, we need a lubrication fluid on the cylinder liner to ensure a proper engine functionality. And there is always a small amount of oil also participating in the combustion, which will create CO2 measurable at the tailpipe. But this amount of CO2 is really, really small. Coming to the second really important composition of emission gases, that is nitrogen oxides, NOx. So we see with hydrogen the potential to really decrease these emissions compared to diesel engines and to get them on a level where they have rather low impact on the air quality in inner cities.
Mm-hmm, mm-hmm. I fully get the point on the, let's say, zero CO2 performance, which I guess is also a main driver to apply H2 ICEs in solutions where CO2 targets are strengthened significantly. Now, looking, for instance, into the heavy-duty sector in Europe, where OEMs need to comply with very, very stringent CO2 targets already 2025, but also moving forward 2030. Now, the other discussion I think we see is the topic of zero emission zones in cities, local usage. Do you believe that under given boundary conditions and considering the current political discussion we have on zero emission zones, that H2 ICEs can and will play a relevant role?
Yeah, there are basically two concepts which could open the opportunity to also enter zero emission zones with the hydrogen engine. The rather simple approach would be to put more electrification into the powertrain, to go for serial hybrids, which are then equipped with a larger battery compared to parallel hybrids, and using the H2 ICE as a range extender or onboard power generator. And as soon as you are entering zero emission zones, you would go for pure electric driving within these zones. Mm-hmm. And the other possibility would be talking about zero emission zones in terms of zero impact. So if the combustion engine itself, with it emitting nitrogen oxides, should not have any impact on air quality, that level can be achieved with hydrogen engines.
Understood. Clear. Lukas, what do you believe is the absolute key challenge to further roll out H2 ICEs to also relevant to a wider, let's say, a market rollout?
There are clear advantages of the ICE in terms of robustness, durability, and we think also customer acceptance will be a quite easy step to just change the fuel than rather change the complete powertrain concept, talking about BEV or other electrified powertrains. And we see a major challenge in terms of efficiency because that is one drawback the ICE at the moment definitely has against the fuel cell, and therefore increasing engine efficiency and making it more competitive in that term is a key for future success. And then, as you mentioned, the topic of pollutant emissions, to get them on a level where air quality in inner city driving is not impacted by the operation of a hydrogen engine in the city.
But I guess, Lukas, that's also good news that there's further development and improvement potential. And of course, we as FEV Group, we are a trustful partner to deliver that challenge and deliver the right solutions. Lukas, that was very, very insightful. Thank you very much for the information and discussion.
Thanks.
Lukas, as I just said, that was very insightful, very interesting, not only for me, I think for the entire audience out there listening to us, watching us. Can you please summarize again what are key advantages, but also key challenges of H2 combustion engines for a wider market rollout?
Yeah, for sure. So the key advantage, as mentioned, that carryover of 80% basically existing technology, so well proven, well experienced. And then for sure the challenge is that new 20% with the focus on the DI injector in combination charge motion, mixture preparation, mixture homogeneity to really get highest engine efficiency and lowest emission levels. And summarizing these advantages, for sure, they are also interesting to other applications. So as you mentioned at the beginning, the announcement of Toyota to realize that passion and that feel of vibration, all that spirit H2 ICE have created in the past, that's possible to carry that over with hydrogen into the decade of CO2 neutrality. And we see therefore that increasing interest from the heavy-duty industry now spreading out, light commercial vehicles, passenger car, rail, all the business is now increasing focus in that interesting topic, and we are really happy that it develops in that way.
Clear. Thanks, Lukas. I think that is on the spot. Everyone out there, I hope you enjoyed our second episode on Tech Nuggets with today's topics, hydrogen engines. Please provide us with the feedback on podcast@fev.com. We are always happy to hear back. You can also contact Johannes or myself directly via LinkedIn. No problem at all. Lukas, I wish you a very good week. Many regards to Germany, and thanks again for that very interesting discussion.
Yeah, greets to Spain, Patrick. Also have a nice week. Bye-bye.
Bye.